maybe we'll wait a couple more minutes, try to get a few more people in. Definitely expecting a few more than this, so let's wait a minute or two. Although last time a lot of people came late, so maybe that'll happen again.
On the other hand, I think more people have since dropped out from the class, so anyways, that is okay. I mean, it's all recorded anyway. Yeah.
Mm-hmm. Okay. Well, just to start things off, maybe we can go through the Slido questions or question. Let me pull it up real quickly. There's only one from this week, so if anyone in the Zoom room has any questions, we can address them afterwards. Let's see here.
Or maybe generally, how are you guys feeling about assignment one in general? Does it seem manageable? It is supposed to be challenging. Obviously, it's a lot harder than there's a lot more work involved. But yeah, if you have any general feelings about how does it look from here, let us know.
Like the assignments, cool.
That's great. Yeah, I know it looks like it's a lot of work, but I think it's especially for the third question about Dark Forest. The Once you realize that you don't have to write the whole thing from scratch, I think it will be a lot better. If you just look at the question, it can look a bit frightening because like you have to build a game, but you really don't have to. It's just to get your hands a little dirty. So hopefully that's fine.
And has anyone here played Dark Forest before? Oh, cool. I have not. I've watched many videos of them showing gameplay, and I feel like I need to play it. I've been waitlisted, yeah, whitelisted.
Yeah, likewise. I think a while ago it's very easy to get on, and now it's gotten so crowded. Is you have to wait a while before you get even let you play.
Mm-hmm. All right. Well, so in the so the question in the on the forum is pretty much just a direct question from the homework. So it just says, is there any hint for why the chain identifier is necessary to prevent double spending? So does anyone want to like make a pass at that in the chat? I can elaborate on it if no student has anything they want to say. So I mean, so one thing about when you are maybe hashing some data together. Oh, here we go. Cool. Let's see what people wrote. Yeah. So the nullifier for one can essentially track which like transactions have been have occurred, and furthermore, as you see, if you include like a chain identifier in the hash, it's going to be a piece of information that will then be hashed to the tree, and then therefore the value itself is going to be unique. So you can think about it as a way of when you incorporate these things into your kind of your commitments, it makes that piece of data unique to that tree, and therefore you can't just move it from one tree to another if you just have your secret and the amount value. And it's really important to think about this in relation to the next question when you start sketching out the proof, the zero knowledge proof, because yeah, it comes into play there. Oh yeah, zku beat me to it. So also one thing that I'm wondering is has everyone here watched and preferably rewatched Drew's video on that we sent across? Because he explains a lot of the reason and motivation behind these including these indexes quite well. And if you have any more questions about it, definitely watch Drew's video. I think it's probably one of the more useful things we've included in the materials. Even if I use the same proof in the different tree, I still need to already have the funds in there to withdraw. So how does so when you think about yeah, the mixers, you're wait, let's see. Samar might have answered this. So like we're putting kind of all of our money and mixing it into, say, like a pot, and we withdraw it. If you don't have a nullifier, you can maybe just say like, oh, I put $50 in. There's not a direct mapping necessarily to which ones are yours. And so the idea is that you could take $50 out twice, 3 times, unless if you have, say, something like a nullifier that will link the transaction you made with the mixer to something to verify that it hasn't been called more than once, because you can just check if it's been called once. I'm just going to yeah, so I think some of these questions are actually really well addressed in Drew's video. Did you watch Drew's video, Tan? Okay. Let me scroll down to question 1 real quick. Question 5. Sorry, I'm just looking through my my notes on the question so I can answer it concisely. I'm still learning these things, so I don't have ready-made answers right off the bat, but let me just see what I have down, and then I'll answer that, Zeke. So so kind of to as I understand it, and someone please correct me if I'm wrong. The way I understand it is one way to essentially in a mixer how to prevent the double spending is you just include the nullifier in the hash, and that is how I would do it, rather than having, say, like a list in which you index. But maybe that's not correct, and maybe someone should correct me if there's a better answer to that. Okay. Was that at all clear? All right, here we go. Correct. So by making the, so that maybe that's better specified than what I was trying to say, but by including, say, the index value in the proof, it's going to be unique or specific to that unique chain, and therefore you know which one it belongs to.
Yeah, I think the tree identifier is in addition to the nullifier as part of the, so originally you will be hashing the nullifier and the secret, right? And now you are hashing the tree identifier plus the nullifier plus the secret. So the idea for double spending doesn't really come when it's already past the time that the block would be verified. So the idea of double spending is when things happen very quickly, and in a way when the two chain are not well, I'm not sure this is the correct terminology in the field, but yes, exactly. So I don't think, but you're right, like you still need funds in the tree. So usually when we talk about double spending is when it's so happening so quick that the block is not verified yet.
So maybe if we consider this resolved, we can go back to another question. I saw Seki D as a question about part 1 and question 5.
Yeah. So that's the one in a mixer, prove how to prevent double spending with another scheme beyond hashing the first element of the secret set. So I don't know if I have a great answer to that currently. Does any of the students have one? So we have someone said hashing the second secret element. Yeah, I mean, I think this kind of goes beyond the content of his, hashing a timestamp. That's interesting. how would that work? Can you expand on that a little bit? I guess like the now variable and hash it. Yeah, I'd have to think about how that could help with double spending. Yeah, I also wonder if like, but in this answer, let's say it's okay. Here's another one. Let's see what they say first. Oh, yeah. Yeah, and I mean, if there's probably a small enough window where you can maybe infer a timestamp with some higher degree of certainty than you'd want. I mean, it's interesting. I think it's a good way to be thinking. It's kind of beyond the contents of the video, so that means it's going to require some creativity, which is definitely difficult when it comes to these concepts. Yeah. As so Drew kind of sketched some pretty basic like sequence of variables and just specify which ones you'd hash and stuff like that in the lecture. So something just similar to that degree of specificity could work. If you wish to actually implement the circuit for that question, you should do it. But there's a related like the bonus requirement can probably suffice as well. So the idea for like, just to like reiterate, the idea for just sketching would be like, external pseudo random data.
Yeah, I was also thinking that yeah, we'll go back to the 0K proof question in a bit, but I was also thinking that like if we hash something with the nullify with the timestamp right? Not using the timestamp itself, but a kind of a pseudo-random thing. Basically anything that is random that is not known by some external person, right? Because the problem is not whether it's saved or not, because the nullifier is saved inside the smart contract anyways. So it's really for anyone external to not have a deterministic way to know what the nullifier is. So pretty much there's a lot of creative answers here that is possible. Right. But going back to the 0K proof question, does that make it clear? Oh. Yeah, so that was what we were talking about. So in the original scheme that Drew kind of outlined in the video, you just used the first secret as the nullifier. But it really doesn't have to be. Right? It could be just basically anything that could identify that transaction, be it the deposit that goes in or.
Yeah, and as he gets kind of in the generalization section of that talk, he shows about the types of, or the collections of data you may be hashing. And so it's good to maybe think about in relation to this, like if we were to maybe move this beyond the simple applications that he proposed here, like maybe we want to not only mix one type of asset, but maybe different kinds. What types of things will we need to include into those proofs to identify that, oh, we have different types of assets here and we want to make sure that everything's being mapped accordingly. So yeah, I think it's probably good to think about that last section also in terms of maybe as inspiration for final projects as well, because it's rooted in some of the stuff that he talks about in some of these assignments. And yeah, is a nullifier part of the secret or something else? Yeah, Cathie addressed that. Also, has anyone looked into the tornado cache stuff? Fairly related to some of the things we're doing right now, and probably pretty important to be updated before Thursday, and maybe have some good questions prepared. Yeah, one thing that still confuses me about tornado cache is, yeah, on their GitHub, the tornado trees file. I know Hakwan, Cathie, and I have tried to look through it, and it's currently above my pay grade to understand it, but I'll try to, I'm really curious to see if I can better understand it by Thursday.
Yeah, hopefully the Thursday class would help. We can hopefully resolve it there. But yeah, I was thinking like, so it's quite a small class. So if you guys want to just speak up, you can also do that and unmute yourself. I think you are able to. Yeah, and otherwise there are some questions from the Discord channel. Maybe we can try to address them too, shall we?
Yeah, pull it.
It looks like some might be pretty straightforward.
Yeah.
I can try to paste them here.
Oh yeah, if you can paste them, Hakwan, let me know which one. Also, shadowy supercoder.eth had some really nice examples with regards to last week's questions that I highly recommend going through it. And thank you if you're in this Zoom call right now. It's really helpful. All right, let's see. So you can just use remix, as I think Cathie addressed in the channel. I mean, of course, play around with creating functions because you can then extend it. Yeah, it's been really crazy, not crazy, but really funny trying to map all your creative Discord names onto faces and emails. It's kind of fun to be in a class and you're interacting with people whose name is Shadowy Supercoder. I think that's pretty fun. But yeah, so definitely if you, the goal for the assignment is to use minimal gas. I mean, we'll definitely, if it's, say, if two students turn in very good assignments and one has less gas or uses less gas for a specific question for their Solidity program, that's definitely going to be looked favorably. So whatever you can do in that regards, you should. But also if you wish to write functions and then generalize them and kind of riff on what we've put here and maybe show us something extra and something cool, feel free to just include that as some bonus content if you wish. So yeah. Part 6. Yeah, so implementing the circuit is extra. It's a starred question. So it's if you end up doing that, the description of the variables can just be seen as something analogous to maybe even just commenting them out, or if you want to go a little bit farther, describing things in more detail with how stuff is happening under the hood. I think one of the most, I know, I mean, for me, one of the more difficult parts of using circuits is a lot of stuff happens under the hood kind of for free, and it's not so obvious at a first pass exactly what is going on. And so explanation of those things is always appreciated, because then we also can learn how to teach this stuff better because we can crowdsource good explanations and everybody wins. Yeah, so the greatest common denominator part is maybe one of the hardest parts of this assignment, actually implementing that. And seems like some of us are getting to there. It requires a pretty, yeah. Definitely an extension of circuitry knowledge from last week, that is for sure. And I know there are some worries about the like the single line versus the equal sign operator. I went through the documentation after you asked that to try to get a better sense of why it's unsafe, and it seemed to be very minimal explanation, if no explanation about why it's safe. But
with the GCD implementation, the thing is, it wouldn't be possible with the double line, because if you look at any algorithm that computes a GCD, it's a if else statement. So it's a round of sequences of if else statements that is never going to be linear or quadratic. So then if you try to implement a constraint on that rather than a single line, so a single line is an assignment, right? And a double line is a constraint, then yeah, it's not going to happen. So as far as the documentation said not to do something like that, we still have to consider the actual feasibility of not using, using a constraint in that case. So the case for the GCDN, the prime, is normal to not be able to use the double line constraint. But that being said, you still have to use the constraint to check those values back in the actual main circuit itself. Right, so to check that it's more than one, then that is an actual constraint that you can set up. Cool. Great. I think someone also sent out some resources on the distinction between the double line and the single line in circle.
All right, I'm going to watch that.
Thanks.
Yeah, and feel free to throw it into the chat in the Discord as well. Many people will probably find it helpful. So I'm looking through the Discord, seeing if there's anything worth bringing up. I guess I'm curious, have many of you gotten into the dark forest question yet? That one will probably be pretty tricky. So yeah, cool. Well, good job. Nice. All right, yeah. Yeah, I mean, I feel like I've everything I feel like in tech, you feel like you're playing catch up no matter what you're doing. So that's probably good practice. What kind of back-end problems? It's 5 minutes.
Let me try to dissect the question a little bit. So first of all, the zero forest question, dark forest question is there's two parts, right? So you have to code both in the circum, which is usually the part that is computed locally. So that is only all the single users rule that you can verify, right? So that means probably the first 3 rules. Then there are the other part that you have to compute on the smart contract itself. So in Solidity, right? So all the cross-player stuff, you will have to compute in a smart contract, right? So all the things that can control whether different players can be at the same position, how long each kind of spawn has to be apart. So those will have to be controlled in a smart contract. It's probably easier for you to just create your custom little contract just to do the spawning for now. Does that answer the question? Yeah, and for the very last part of the question, which asks you to compute an interface, it's just the coordinates of the games. Yes, yes. So just to show us that, like show us the input that actually gets into the circuit, and then the whole process of it going through to the to being a hashed ZKP and then uploading to the smart contract itself. So to make it more of like an interface that is kind of playable or a command line game, you might find that Remix IDE is not sufficient to kind of streamline the process, because you know how if you use Remix IDE, then your inputs have to be kind of manually put in instead of kind of a command line interface. So I mean, it's up to you guys how to streamline this process, but another tool that you can look into is Truffle, which also work well with Ganache, which is the recommended virtual Web3 server locally anyways. Oh yeah, or Hardhead, of course. Okay, is there any other question?
All right. Well, seems like we probably exhausted all of our questions for right now. So we could probably wrap up. If, of course, our Discord DMs are open and the public channel is as well. Public channel questions are definitely where you should definitely send all questions to the public channel, so everyone can see and everyone can benefit. So yeah, if that's all for today, looking forward to Thursday. It's going to be a lot of fun and trying to learn a lot of cool stuff. All right. Well, if Hakwan or Cathie have nothing to say, I will bid us all farewell.
Thank you. Thank you.
Thanks, guys.
Thank you.